Hi guys, welcome back to my YouTube channel. We're given question 2 and we have 2.1 says a truck of a mass. We're given this mass 4,500 kg travels at a constant velocity of 50 kilometers per hour while towing to bucket B of the mass 1,250 kg. The engine of the truck produces a force of um 11,270 newtons, and the road surface exert a frictional force of 8,820 newtons on track A. So what we have there, and then 2.1 says write down the Newton's second law of motion in words. um that is, as you can see here, this is what we have. um when you can say Newton's second law of motion, when a net force applied, okay, or acting, same thing, when applied on an object, will cause the object to accelerate in the direction of the net force, and this acceleration is directly proportional to the net force and inversely proportional to the mass of an object, right? So 2.1.1 says draw the free body diagram showing all the forces acting on track A. The length of vectors should be an indication of their relative magnitude. So this is important. The length important here. So track, we're focusing here. Track A, do you know this is a horizontal surface? Then we'll simply have um the freeport diagram here. We'll have a weight going down. Also we'll have FG, F normal, this is normal. You will have FG, then here applied force, F applied, then applied mass below friction. Here we have F, can see FK, then here we'll have can see tension. As you can see, they are not, we have tension there. Right, as you can see, Fk is greater than T. Right, this is our free body diagram. If tension will become greater than friction, it will tear up. So okay, so let's calculate 2.1.3. Calculate the coefficient of kinetic friction for the tire rubber on the surface. What we know is that kinetic friction is equal to mu k multiplied by the normal force. So by the normal force is equal to weight, which is mg. So we have mu k multiplied by mg. Here we have fk. So this we are given. If you can check there, it is here 8,820. 8,820. You want the coefficient of friction. What about the mass of that truck? A is 4,500 kg multiplied by gravity. Then you can divide both sides by 9.8. This and this will cancel. We'll have 500. Then the form mu k, when you punch that, will be 0.2. There is no SI units. Right, so this is what we have there. Then calculate the force of friction exerted by the calculate the force of friction exerted by the rod on Paki P, or 1D on Paki P. We want calculate. Okay, that is so simple because Paki P, we know this free body diagram will have normal force and weight. So as you can see, we can use the same equation there. Apply the same equation. We know that kinetic friction here is talking about it is back, right? It's a backy. So Fk must be equal to mu k multiplied by normal force, whereby this you've calculated equals 0.2. This is the same as mg, the mass of the backy. What is the mass of the backy here? It's 1250. 1250 multiplied by 9,8. Let's find the friction there. What will be a friction? 0,2 multiplied by 1250 times 9,8. This is simply equals to 2450. It's measured in newtons, right? What done with that? Then 2.1.5, calculate the tension in the tow rope. We want this tension there. Can use this free body diagram to calculate that. Just you can use this free body diagram. We know this is at a constant. It's at a constant velocity. That means acceleration is equal to 0 meters per second squared, right? Then also F net must be equal to 0 when at a constant velocity or at a constant speed. Acceleration is equal to 0, F net is equal to 0. So we know that F net will simply equals to 0. Here we'll take we'll have FA and minus the one that going minus Fk friction minus Fk minus tension. This must be equal to 0. What do we want? We want the tension. So since I want the tension, I can say F applied minus Fk, and take this to the other side or add that to the other side. I will have, if I add this, I will have this. So what is F applied? 11,270 minus the friction. Remember, minus the friction. Remember, we're focusing here. It's 8 of friction, 8,820. 8,820. This will give us T, then 11270 minus 8,820. Our tension, therefore, tension will be equal to 2450. This is in newtons, so this is what we have here. Thank you guys for your time. This is what we have. We're done with our question. So guys, thank you for your time, and please don't forget to subscribe to my YouTube channel, right? Thank you, Lord. Thank you for your time. Stay blessed.